Hi everyone, let's continue. Last time we talked about substitution and we work on the problems on indefinite integrals. Today, let's continue for a definite integral. We let u be the inner function, okay, where g prime is continuous on an interval and let f be continuous function on the corresponding range of g. So here we let u be the inner function, and then du is g prime of x dx. So that's why we can replace this guy by du to get integral about u. Okay, so here we gotta be careful. So those bounds, a and b, they are x values. So when you want to change to a u integral, you have to change the values to u values. Okay, so these are u values. And what you can do is you either change the limits of integrations and calculate the definite integral of u, or you can use U-substitution to calculate the indefinite integral of x and evaluate the x values. So just make sure you either plug in the u values for u or you plug in the x values for x. Okay, so I will do both so that you can compare. Okay, then you can pick one of them to work on. Okay, so yeah. All right, so first of all, let's look at this problem. Okay, so let u be the inner function, so that is our u. Okay, and then du is 3x squared dx, but we don't have 3x squared dx, we only have x squared dx, so that is 1/3 du. So far so good. Okay, so for this way, let's change to the u values. Okay, so this is the first way. Okay, and we change the u values. Okay, so that's why we have u of -2 and u of 4. X squared dx is 1/3 du. And then we have u squared. Okay, and what is that? Well, u of 4. What is u? U is x cubed plus 8. So u of 4 is actually 4 cubed plus 8. 4 cubed is 64. 64 plus 8, 72. Okay, and u of -2 cubed is -8. -8 plus 8. Oh, so -2 cubed plus 8 is actually 0. Okay. See, now we change the x values to u values. And then what do we do next? We can integrate it. So this is u to the cube over 3, evaluate from 0 to 72. Okay. Well, that's 1/9. 72 cubed minus 0. Oh, so the answer is 72 cubed over 9. Wow, what is that? Let me put it into the calculator. So 72 cubed divided by 9. My answer is 41472. Okay, so that is the first way where you change to the u values and plug in the u. Alright, second way, let's keep the x values and we need to get the x back and plug in for x. So the second way, okay, so the same thing as the previous, we do u and du. And then 1/3 du is x squared dx. Okay. So after you're done, okay, so you get the integral equals 1/3. Here, u to the -2 and u to the 4, u squared du. So here, don't change the u values. So always keep it as, so integral of u cubed is integral of u squared is u cubed over 3, and then we have u of -2, u of 4, okay? And then we plot the x back, so that's 1 over 9. U is x cubed plus 8 cubed. Now, because we get the x back, we can get -2 and 4. So we plug in 4 first, so 4 cubed plus 8 and cube minus, we plug in -2. And you realize this is 72 cubed over 9. This guy is 0, so we still get the same answer. Okay, so which way do you prefer? So you either plug in the u values into your u, or you plug in the x values. Okay, so keep the x values and plug in for x. Okay, don't put your u values into x, or don't put the x values into the u. So we gotta be consistent. Okay, so this guy is changed to u values. Okay, so far so good. We have 2 ways. So pick one of them as you like and then stick to it. Okay? All right. So let's continue. Which way do I prefer? I personally prefer change the u values. Okay, because it will simplify the problem a little bit. Okay, so let's continue. Okay, so first, let u be the inner function. Well, here the inner function is this guy, right? U is 1 plus 2x squared. Well, then du is what? 2 times 2, 4x dx. Well, here we don't have 4x dx, we have x dx. So x dx equals 1 over 4 du. Okay, and then let's put it in. My integral is u of 0, u of 2. X dx is 1 over 4 du. And we have 1 over square root of u. What is u of 2? So 1 plus u of 2 is 1 plus 2 times 2 squared. 2 times 2 squared is 8. 8 plus 1, 9. U of 0, oh, is 1. Okay, doesn't u to the -1/2 du. Okay, u to the -1/2 is u to the 1/2. Divided by 1/2 is the same as multiplied by 2. Okay. Alright. So evaluate from 1 to 9. And they cancel, we get 2. So 1/2. We plug in 9 first. Square root of 9. Minus, we plug in 1. Square root of 1. Oh, square root of 9 is 3, right? And then, oh, that's 2. 2 over 2. Oh, the answer is 1. So far, so good, everybody? Okay, so you can see I changed the u values and I don't need to plug in my x back. Okay? Part C. Alright. So we let u be the inner function. So here the inner function inside the power is this guy. So u equals 1 plus square root of x. Du is integral of 1. Sorry, derivative of 1 is 0. Derivative of square root of x. Square root of x is like x to the 1/2. So that is 1/2 x to the -1/2 dx. Well, that's the same as 1/2 and 1 over square root of x dx. So, our problem, you can see our problem, we have 1 over square root of x dx. So 1 over square root of x dx is 2 du. So my integral is u of 1, u of 9. And then dx over square root of x is 2 du. So put the 2 in front, du at the end. Then we have 1 over u squared. Okay, that's the same as... Oh, by the way, what's u of 1? 1 plus square root of 1 is 2. u of 9, 1 plus square root of 9. 1 plus 3 is 4. Okay, then u to the negative 2 du. Oh, what is that? Integral of u to the negative 2 is u to the negative 1 divided by negative 1. So it's the same as multiplied by negative 1. Evaluate from 2 to 4. So let's plug in, let's rewrite this. That's the same as 2 over u, plug in 2 to 4. So we plug in 4 first. Minus negative become plus. We plug in 2. Oh, that's minus 1/2 plus 1. The answer is 1/2. Do you have the same answer? Yes. Okay. And part D. Yeah, don't forget you pause the video for each of the problem. Please pause the video and then try first. Okay? And after you're done, you can check your work. So that in that case, you have a lot of exercise. We learn math by actually doing it. So this is good that we had a video. You can pause anytime and you can have a lot of chance to practice. Okay? So same thing, we let u be the denominator. And du is, oh, this is same as before, right? 1/2 x to the negative 1/2 dx. So that's 1/2 1 over square root of x dx. Oh, but my square root of x is on the numerator, not in the denominator. What do we do? So let's see. So this problem is a little bit challenging. Okay. So you want to create. So here we have 1 over square root of x dx is then 2 du. You want to have 1 over square root of x in the problem. Okay. First of all, let's copy it. This is what we have, right? But I want to have square root of x at the bottom. What do we do? Well, we don't have it, but then just multiply, just create it. But you cannot just divide it by square root of x. You also need to multiply by square root of x. Then this guy together will give us 2 du, okay? So see now, we have u of 0, u of 1. dx over square root of x is 2 du. What's left? Well, what's left? You can see square root of x and square root of x multiplied together will give us x. Okay? X is square root of x times square root of x. The bottom we have 1 over square root of x. Okay, that's not good because let me see, this is a mixture of u and x, okay? So we're gonna change this. What's 1 plus square root of x? Well, that's u. Okay, and what is x? So square root of x times square root of x is x. But what is x? Well, how do we find x? Solve for x in the, this is a formula about u and x. Solve for x here. So we subtract 1 from both sides. And we square it. Okay, so x is u minus 1 square. We put u minus 1 square here. Okay, so this is the process, how we think. And let's continue. U of 0, 1 plus 0 is 1. U of 1, 1 plus 1 is 2. Okay, so here we have fraction. We're gonna multiply out and split, right? So u minus 1 square is u squared minus 2u plus 1. And u du. And then what's next? Let's split. So we have 2 integral 1 to 2. U squared over u is u. 2u over u is 2. And 1 over u. du. Okay, let's integrate it. Well, u squared over 2 and 2u, and that is ln of absolute value of u. Plug in 1 and 2. Okay, let's see what happened. So we plug in 2. Well, we have 2 squared over 2, which is 2. 2 times 2, 4. ln of 2, right? And then we plug in 1. 1 over 2 minus 2. And ln of 1. By the way, ln of 1 is 0, so this guy is gone. Okay, so 2 minus 4 is negative 2 times 2, negative 4 plus 2 ln of 2. Minus 2 and 1/2 cancel, we get 1. Negative, negative can become positive. Positive 2 and 2, 4. So, wow, we get this guy cancel. We have 2 ln of 2 minus 1. Okay, so this is our answer. Do you have the same answer? All right, so let's continue. Okay, so let's look at next problem. Well, next problem, you see a product of sine, cosine. We know, no, we don't have product rule, right? Okay, but can you see the inner function? We have a composite function, sine to the 4. Can you see that? And if we let u be the inner function, which is sine x, can you see there is a cosine? Well, cosine is exactly the derivative of sine. Okay, so in this case, U-substitution work. So let u be sine x, and then du be cosine x dx. And then our integral becomes u of 0, u of pi over 2, sine, which is u to the 4th. Cosine x dx is exactly du. Oh, okay. What's u to the 0? U of 0. U of sine 0 is 0. U of pi over 2, sine pi over 2 is 1. Okay. So integral of u to the 4th. Well, that we add 1 to the exponent and divide it by the new exponent. Evaluate from 0 to 1. So 1 over 5 minus 0. Oh, so the answer is 1 over 5. Okay. Very easy, this problem. So far, so good. Okay. So you can see this cosine, the presence of cosine x dx is so important because that will contribute to the du. Okay. If we look at part H, okay, if we have sine x dx, then we can let u be cosine and then du be sine x dx. But here we don't have sine x. Okay, so I'm going to look at this problem. So if we try, okay, if we want to try the u substitution, if we let u be cosine x, well then du be minus sine x dx. Then when you try to plug in, you have u of 0 and u of pi over 2. And then you have u squared. But the dx, what is the dx? You cannot solve the dx in terms of u. The dx is, you cannot put like, oh, dx is du minus sine x. No, you cannot do this. So we get stuck. So actually in this problem, we cannot use u substitution. Okay, u substitution cannot help us to solve this problem. So that's why the presence of du is so important over there. Okay, so actually what do we do is we use double angle formula. Okay, so this is the correct solution. Use double angle formula. What is double angle formula? Well, that is sine 2x equals to 2 sine x cosine x, and cosine 2x is 2 cosine x squared minus 1. It's also the same as 1 minus sine x squared. Okay, so using this formula, then you can solve for cosine. So cosine squared is 1/2 plus 1/2 cosine 2x. Sine squared is 1/2 minus 1/2 cosine 2x. Okay, you can see what happened. Using the double angle formula, I can double the angle, but I can reduce the power. So what happened? Our integral becomes 0 pi over 2. Cosine squared is 1/2 plus 1/2 cosine 2x. You can see now we're able to integrate 1/2 and we're able to integrate cosine 2x. Okay, so the double angle formula is so powerful, especially when you see an even power. Okay, so use double angle formula when you see a sine or cosine to the even power. Okay, so when you see sine, cosine, they're to the even power, think about the double angle formula. Okay, so we'll talk about that more in session 7.2. Okay. Yeah, calculus 2. All right, so integral of 1/2 is 1/2 x. So integral of 1/2 cosine. Well, then think about is sine. Derivative of sine is cosine. So it's sine 2x, but we have an extra 1/2 there in front. Evaluate from 0 to pi over 2. So we plug in pi over 2 first. 1/2 pi over 2. Plus 1 over 4 sine 2 times pi over 2 is pi. Oh, what is sine? So at pi is 0. So this guy is gone. Subtract 1/2 times 0 is 0. Sine 0 is also 0. Oh, so the answer is pi over 4. Okay, so this is the correct answer. So far, so good. So this is how we can use U-substitution to solve definite integral. Okay, you either get an integral about U and change the x values to U values, and then you plug in the U values into the U and solve it. Or you can always keep the x values, but you have to integrate it and then plug in your x back. Then you can plug in the x values for x. Okay, all right, bye.